last time I introduced the Maxwell equations, and I will continue to upload the videos regarding the EM theory. So today is the topic solving Maxwell equation, introducing the potentials and the wave equations. So earlier I have also shown the four Maxwell equation I have explained. Del dot E equals to rho by epsilon naught, del dot B equals to 0, del cross E equals to minus del B del T, and del cross H equals to J plus del D del T. You can also write it del cross H in terms of del cross B, that is mu naught J plus mu naught epsilon naught del E del T, or you can write it mu naught J plus 1 by C square del E del T, or you can write J by epsilon naught into C square plus 1 by C square del E del T. The forms are same. Okay. So here I will introduce the potentials. Now whenever the del dot B, that is the divergence of the magnetic field, is 0, so you can express B as a curl of A. From where does it come? If the divergence of this quantity B equals to 0, then divergence of curl of A will also be 0. So B can be expressed as curl of A. Now, why this is called vector potential? Is this potential energy or what is this? What is it? We all know that force can be defined from the derivative of a potential, F equals to minus grad V. Okay. So here the curl, you can also think that the curl is a operation like a derivative. So derivative of a potential, that will give you the magnetic field. So that's why it is called vector potential. This is not potential energy, just the conventional thing that whenever you take derivative of potential, you will get force, or here you take derivative of the magnetic vector potential, you will get the magnetic field. Okay. Now we get B equals to curl of A, and also the Maxwell equation tells curl of A equals to minus del B del T. So you put here minus del B del T or del T of curl of A inside, in place of B you put curl of A. So you get curl of E plus del A del T equals to 0. You take the curl outside and you put the two quantities together and making the right hand side equals to 0. So the curl of any quantity is 0. Suppose curl of E equals to 0, then E can be expressed as minus gradient of some scalar field. So here I also can write the total E plus del A del T equals to minus gradient of phi. Why we take minus? Minus just for the convention that if we compare this whole thing with the electric field, if whenever the electric field is static, that is there is no variation of del A del T will be 0, there is no dynamic electric field, then E will be, for static electric field, you will be minus grad phi. So here E plus del A del T equals to minus grad phi, or electric field can be expressed as E equals to minus grad phi minus del A by del T. Okay. So you get the fields, electric and magnetic fields, in terms of two potentials. One is the scalar potential, another is the vector potential. And one thing is to remember that magnetic field is associated with the vector potential and electric field is associated with the vector potential as well as the scalar potential. And the association of the vector potential will be dynamic, that is the variation of the vector potential with respect to t. Okay. Now there is a question, is A or phi is unique? Is this potentials, the scalar potential, magnetic potential, are unique? Because E field and B field we can measure. These two are measurable quantities, so they have unique values. Point to point they may vary, but at one point it is constant, for another point it is fixed. I mean, they have unique values. But is the choosing of A or phi will be unique or not? So I have also told you that curl of A is B. Now if you replace A with A prime such that A prime equals to A plus gradient of some function, scalar function psi. So you take A prime equals to A plus grad psi. So curl of A prime will be curl of grad psi, that is curl of A plus curl of gradient of psi. So curl of gradient of psi will also be 0. So it will also give curl of A, that is also give you B. So curl of A also giving you B, curl of A prime is also giving you B. So the choosing A is not unique, but whenever you place A in place of A, you put A prime, the magnetic field will be B, constant, I mean unique, but the electric field will vary, because electric field is also function of phi and function of A, that's function of scalar potential as well as function of vector potential. So if you change A to A prime, there will be an extra quantity here and the electric field will be changed. So if you change vector potential, you have to change the scalar potential phi to phi prime such that the overall change will be 0. That is, the electric field and magnetic field must be the same after changing the A and phi. So you should change phi prime accordingly, and that change will be phi prime equals to phi minus del psi del t. So if you put here E equals to minus grad psi, in place of grad psi, you put minus grad of psi prime, that is psi prime will be psi minus del psi by del t and minus del t over. In place of A, you replace it with A prime, and A prime will be A plus grad psi. So you simplify it, minus gradient of phi minus plus gradient of del t of psi minus del A by del t minus gradient of del t of psi. So plus gradient of del t of psi minus gradient of del t of psi. Both quantity will be cancelled. So you will remain. I was telling you, whenever you change the potential, that is vector potential, you have to change the scalar potential as well as the scalar potential just to unique the magnetic field and the electric field value to be unique. Okay, and this is called the gauge invariance. So A is not unique and phi is not unique, but E and B are unique. So here now we can write the Maxwell's equations in terms of A and phi, that is in terms of scalar potential and magnetic potential. And if we find out the solutions of the scalar potential and magnetic potential from the B, A, that is magnetic vector potential, we can find out the value of B, and from the magnetic vector potential and the scalar potential we can find out the value of E. So from potentials we can get the values of E field and B field. Now Maxwell first Maxwell equation is divergence of E equals to rho by epsilon naught. So in place of E we write minus grad phi minus del A del t equals to rho by epsilon naught. So here simplifying it, minus del square phi minus del t of del dot A equals to rho by epsilon naught. This is our first equation. And another equation from the equation 4, that is maybe this, all the forms are the same. So I take the j by epsilon naught form, that is the last form. So c square, I take the c square here. So c square into curl of B minus del E into del T equals to j by epsilon naught. Now c square into curl of B, we can write it curl of A minus delta T of, in place of E you write minus grad phi minus del A del T equals to j by epsilon naught. So simplify it, this is a vector identity, that is curl of A equals to del of divergence of A minus del square A, grad of divergence of A minus del square A. So you put here minus c square into del square A plus c square into del of del dot A plus del t of grad phi plus del 2A del t2 equals to j by epsilon naught. Now you take the gradient of del dot A and gradient of phi in one place. So del of del dot A plus 1 by c square into del phi by del t plus 1 by c square into del 2A by del t2 minus del square A equals to j by epsilon naught c square, where you divide by 1 by c square. Okay. So you simplify it. You have to simplify the two equations, that is equation 1 and this equation 2. You have to solve two equations to get the value of phi and a, ultimately get the value of E and B. So how do you solve this? Here you have two gaze. You can have two gaze. One is the Coulomb gaze, another is the Lorentz gaze. For Coulomb gaze, you will take del dot A equals to 0. So whenever you take del dot A equals to 0, your first equation becomes del square phi. Let me write it clearly. It is whenever you take del dot A equals to 0, you get del square phi equals to minus rho by epsilon naught. This is famous Laplace equation, that's for the electrostatics. So if you can solve the equation, this is the phi, if you can solve phi, then you can also solve the E and you can also get the value of A, and from that you can get E and B. Okay, that is the one choice. Then this is called Coulomb case. And another choice you can also make, that is del dot A, that is del dot A equals to 1 by c square into del phi by del t. So this term will be cancelled, this term will be 0 if you get del dot A equals to minus 1 by c square into del phi by del t. So this will be cancelled, and this is called Lorentz gaze. Okay, so if I take Lorentz gaze, this term will be 0 and I will left with this term del square A minus 1 by c square del 2A del t2 equals to j by epsilon naught c square, and del square phi minus 1 by c square del 2 phi by del t2 equals to rho by epsilon naught. Okay, so this is the minus rho by epsilon naught. Now this is the two equations relating to different potentials. One is entirely in terms of the vector potential and another is entirely in terms of the scalar potential. So here also the interesting fact is here the equation is not homogeneous. These are inhomogeneous equations, and the term on the right hand side are telling you the sources of this field. Here the source of this vector potential is J, that is current density, and source of the scalar potential phi is the rho, that is the charge density. Okay, so if you have, means in free space there is no current density, there is no charge density, you have to think that in free space how can we get EM wave, because there is no charge, there is no current, but still there is propagation of electromagnetic wave. How is it possible? So if you, although you don't have rho or you don't have J in free space, but this tells you the wave equations where the velocity of the wave will be c. So here you can exactly think that in free space also, although there is no rho, there is no J, but the propagation of wave is possible with the velocity of c, where c is the velocity of light. That's why electromagnetic wave can propagate through vacuum. Okay, so for now I think it's enough that you all learn the scalar potential, vector potentials, what is it and how do you express it in terms of Maxwell's equations. Next time I will tell you some more physics. Till now, happy learning. Thank you.